Good morning, dear friends. I am Dr. Rajin Linus from Sanjay Godawat University, Kolhapur, Maharashtra. Last couple of classes, we have seen how one can convert ABC to alpha beta, then alpha beta to dq, and also we have derived the torque equation when the reference frame is rotating at the same speed of the stator. So when we go through this entire process, we have seen a lot of mathematical concepts are included, and it is a tedious process to finish it entire thing. So one can easily write the matrix by observation. Let's see how we can do this by the observation. Now in our case, we here previously alpha r is here, beta r is here. We moved this beta r to along the axis of beta s axis. So then we have seen, we have taken this beta ss qs axis and that beta r axis as shifted axis, beta r as bqrf. The yf bqr, that rotor winding is fictitious in this axis. Similarly, in this ds axis, this vds is as such stator winding, but we have moved this rotor to here so that it is fictitious in this axis. That's why vdf for rotor. So now we are going to write directly by the observation what will be the matrix instead of going these tedious derivations. So already we have seen here VDS, then VQS, then V naught S, then VDRF, then VQRF, and we can have V naught R F. This is the voltage matrix equal to, we are going to write it entire this matrix here by observation, then remaining will be, we can write it in this column IDS and IQS, then I naught S, then IDRF, then IQRF, then I naught RF. So we have finished now voltage matrix and current matrix. To write this equation in a good position, I am writing here ds, qs, then naught s, then drf, qrf, and not rf. So we have written this as well. Now first condition, each winding, now in our case this beta r is not there, don't confuse with this, beta r is not at all here. This similarly this alpha r also not here, so you confuse with this. So these two windings are in this x axis and ds axis and q axis. So now, so we have four winding, so each winding is having they are having own resistance and the self inductance. So how we will write normally that resistance and inductance combined for voltage equation, already current is there. So VDS is having impedance with respect to IDS, and VQS is having impedance and multiply with IQS, V naught also like that. So same way I am going to write it here. So Rs plus Ls into P. So what is P? P is nothing but d by dt. P is nothing but d by dt. Then Qs and Qs having resistance plus Ls into P. Then not S and this not S. Let me move this little more some distance. So not S is having, but when we write this not S, there is having the stator resistance, but it is only having the leakage inductance. There is not having any magnetizing component, so only leakage inductance. Then when we do VDRF, we can write here rotor resistance plus L, uh, rotor resistance plus LR into P. Then here also rotor resistance plus LR into P. Then here RR plus LR into P. So now entire diagonal element is finished. Then as far as this zero sequence, zero axis is concerned, there is no other variable, only we have this leakage or this resistance drops only. So here also we don't have any other parameters. Since this is the balanced system, there is no other parameters. We are considering the balanced system. Then we are going to write if suppose when you write the equation of any one of the winding, voltage equation of the any one of the winding, if two windings are in the same axis, it has mutual inductance effect, right? So normally inductance effect L into P, right? Mutual inductance effect 3 by 2 MSR into P, correct? So 3 by 2 MSR into P. Therefore VDS and VDS and VDRF both are in the same winding, so it has mutual inductance. It has the mutual inductance. So therefore VDS, VDRF. So in this place we will have the mutual inductance 3 by 2 mutual inductance between stator and rotor MSR into P. Similarly, when we write QS axis, so QS and QR both are in the same winding. You can see here same axis. Therefore, QS QR we can write here 3 by 2 MSR into P, right? So the same way when we write this equation of VDRF for fictitious winding, VDRF and VDS both are in the same axis. So we can write here 3 by 2 MSR into P. Then VQRF and QS. QRF and QS both are in the same axis. So QR, QF. So we can write here 3 by 2 MSR into P. Okay. Then when we write the voltage equation, if the windings are perpendicular, when you write this voltage equation, voltage equation of this winding, especially we can see, let me take another one color for your understanding. So this is fictitious winding. Similarly, this is the fictitious winding. So when we write the voltage equation of other winding, not fictitious, the same winding, if these two windings are perpendicular, there is having zero voltage. There is having zero voltage. So when we write it this VDS, so VDS with this QS. So VDS and QS both are perpendicular 90 degrees. So there is surely will not have any mutual inductance. So mutual inductance is in terms of cos of theta. So cos 0 is 1, right? So here cos 90 angle between this VDS and QS are 90 degree. Therefore cos 90 0. So similarly, VDS not S automatically both are perpendicular 0. Then VDS VQRF, VDS VQRF, these two are also perpendicular, right? This is the fictitious winding VQRF. VDS is here stator winding, so this will be also 0. Then obviously this ORF is also perpendicular 0. The same way, when we write VQS, so VQS and DS. VQS, we are going to write the equation for QS. So DS is here. Both are perpendicular again. So we can write it here 0. Then VQS not S, again it is 0. Then QS DRF, again it is 0. Then QS not F, not RF, both are perpendicular 0. So now first three rows we have completed. Let us move to the fourth row. So now this is fictitious winding, right? We are going to write the fictitious winding equations. Fictitious winding equations. So when we write the fictitious winding equation, if both the windings are perpendicular, there is having speed EMF term. So normally speed EMF term we will write 3 by 2 MSR into omega R. For example, both the MSR, when it will come, if one winding is in the stator and another winding is in the rotor. So then at the same time, when we write the speed EMF can be like this also, 3 by 2 LR in, sorry, not 3 by 2, only mutual inductance when we do, then only we will get the 3 by 2, otherwise LR into omega R. When it will be, in this case, rotor, and this both the windings are in the rotor. Both the windings are in the rotor, but both are perpendicular to each other. I hope you understand. Both are perpendicular to each other. In that case, you should have LR into omega R. Otherwise, if both the windings are perpendicular, this is only to, you have to consider when you write the equation for fictitious winding. So other cases 0, right? So when we write the equation for fictitious winding, if both two windings are perpendicular and both the winding, one winding is in stator and another winding is in the rotor, so we will have to consider 3 by 2 MSR into omega R. Otherwise, if both the windings are in the same stator or same rotor, here rotor is fictitious, right? So rotor, so we have to write LR into omega. Let us write first, so you can understand. I will take another one color also for making you understand. So VDRF and QS. So this is VDRF QS. So QS is what? Stator winding, but both are perpendicular. VDR is what? Rotor winding. So both rotor and stator. So automatically we have, it will come 3 by 2 MSR into omega R. Then here the case is same, there is no difference. Whenever you are writing this for 0 sequence, nothing to worry, just you can directly write the 0 sequence component 0. It won't accept resistance and the leakage inductance, right? Now here also 0 sequence I have written 0. Now VQRF is fictitious. Now let me finish this. VQRF, VDRF and VQS stator winding, but VDRF and VQRF both are what? Rotor winding, right? VDR and VQR, but both are fictitious. So that case what we have to write? LR into omega R. Similarly, when we write QRF and DS, so QRF is the rotor winding, DS is the stator winding. Therefore, here speed EMF term will come 3 by 2 MSR into P. Same way VQRF and DRF. So both are QR and DR, both are rotor winding. So speed EMF term will be NR into omega, LR into omega R. Now we finished it. Then one more task is remaining. We have moved this direction, right? We have moved. Previously the rotor was here, rotor winding, beta, alpha and beta. So we moved this direction. So which one is leading, lagging here? Lagging is QRF. QRF is lagging with respect to DRF. QRF is lagging with respect to DRF. Therefore, we can write here this is QRF is lagging. Therefore, we can write minus here, minus my speed EMF term of the rotor is having minus term. So now just to verify our previous derivation, see here RS all are there. Then 3 by 2 MSP, 3 by 2 MSR is there. Then this QR of minus terms are there. So now we finish this entire module. In this next session, we will learn if suppose the rotor winding, if the stator winding is attached with the rotor, or otherwise stator windings are fictitious in the rotor, how to derive the entire voltage equation. After that, by observation, same concept, how one can derive it, we can see in the next class. Wish you all the best. Thank you.